In this video, we're going to go over an introduction of function notation. So function notation is a way of defining a function, and it's also a way of giving directions, so to speak, for evaluating a function. For this video, we're mostly going to focus on that idea of giving directions for evaluating a function. So let me write out something using function notation here. So this is what one of these animals would look like, and the function notation piece is what's happening over here on the left side of the equal sign. And there's a few things that I want to say about this before we get into the mechanics of it. That stuff on the left side of the equal sign is said f of x. So the idea there is f is the name of the function and it's a function of x. So we're saying this is a function of x. What that means is the variable is x, and that's what we plug numbers into. Kind of like your car is a function of gasoline. That's what you put in your car to make it go. Well, for this function, we're going to put values for x in it to make it go. Another thing is when we're working with functions, we can define it using other letters, such as g of x. And this is, again, f is the name of the function, so sometimes you need to have more than one name. Just like when you name your kids, you don't name them all the same name. So we'll see them with different letters. And then that changes what we're talking about. So having an f of x and a g of x allows us to have two different functions that we can reference without confusion. Next, this notation does not mean f times x. A lot of time in math when we glue stuff together we mean multiplication. A lot of times in math we use parentheses to indicate multiplication, even though parentheses don't mean multiplication. But here this doesn't mean multiplication at all. It's a totally different thing. It's a naming of a function f, and it's saying that its input or its gasoline, its fuel, will be values of x. That's all. There's no multiplication. It doesn't mean multiply everything times x. It doesn't. We're not going to divide anything off. The f of x will always be there together. So what it does tell us is what the input for the function is. That's it. It doesn't say anything about multiplication. So if I have my f of x here, then whatever is we put into that slot is our input. That's what we're putting into the function. So when it's an x, that's just generically saying this function takes values of x. But what we'll see is we'll put values in that to say, okay, this is what I put into the function to make it go. So let's go ahead and look at some examples. Well, actually, I want to remind us of evaluating expressions first. So I'm going to clear out all these points so we can do something like that. Alright, so we're going to evaluate 2x plus 3 for x equal to 5. So this is something we've already looked at, but I want to remind us of it so I can use it to bridge us into using function notation. So what we do with this is wherever we see an x in our expression, we're going to substitute in a 5. When we do that, we get 2 times 5 plus 3. And then once we get that value substituted in, we just do the math. 2 times 5 is a 10. And then we add 3 to that, and that gives us 13. So that's how we evaluate evaluate an expression. Now over here, you might have noticed that I chose to make my expression the same thing as what I have on the right side of the equal sign with my function here. So that wasn't by accident. So here I wrote out another example, but I'm using the same function that I've already been talking about. So let f of x equal 2x plus 3. And we're asked to find f of 5. So again, whatever we put in those parentheses next to our 5 is saying our input. It's what we are being told to change x into. So this is asking us to do the same thing that we did over here. It's just using function notation to deliver those directions. It's saying put a 5 in for x into x plus 3. So when we do that, it's literally the exact same work we've already done over to the right. Now, sometimes students don't trust me on that, so I just write it out. So that's it. So now we've found f of 5. So when x is 5, what does 2x plus 3 equals? That's what all of this is asking. It's asking the exact same thing. that we've already talked about over here. So I want to emphasize a couple things here. First of all, I'm not really doing any math with the left side here. The left side is just giving me information. It's telling me what to do. You can think of them as directions. The math happens on the right side. So notice over down here, when I work the problem, I'm only working with the right side. Now, some people have a hard time leaving that left side behind, and it causes problems. I encourage you just to take the right side, plug stuff in like you're doing, evaluating an expression, and leave the right side behind, because otherwise it can cause some errors of misunderstanding. But just I want to emphasize here that this is f of x. What we found down here is f of 5. So you would not want to do this. F of x does not equal 13. F of x equals 2x plus 3. So if you do that, you'll be counted wrong for it, because f of x is not 13. That's essentially defining a new function. If you really want to not abandon the left side like I suggest, you would write f of 5 equals 13, because that's what we found. We found f of 5. There's also an f of 2, there's an f of 23, but we were asked to find f of 5, and that's what we found. We did not find f of x. F of x is the general expression, the general function. Alright, I'll do one more of these and then let you try some on your own. Let g of x equal to 2 minus x squared. We're being asked to find g of negative 2. So what that means is we're going to take the left side of our function and plug in a negative 2 where the x stands. All of the stuff around x stays the same. Only the x piece turns into a negative 2. So one of the things that happens sometimes is this negative kind of gets swallowed up and not copied down somehow. But only the x turns into the negative 2. So if there's a negative in front of the x, it just comes down. So once we get that plugged in, we're evaluating it out. So we need to do the squaring first. Negative 2 with parentheses around it squared is going to be a positive 4. So this is going to be 2 minus a positive 4. So this minus just came down, and then this minus got squared away. Okay, so then 2 minus 4 is a negative 2, and we're done. So the function notation part there is just plugging in the value for x, and then the evaluating it down, there's some challenges with what to do with the signs, but that's not about function notation. That's really about evaluating expressions and your skills with that. So go ahead and give some of these a try and see how you fare.